After importing the data set, so let me try to import the data set. After importing the data set, okay, now the next thing is to TS set the data set. So by running the line of code in 28, line 28. So let me run this. So let me confirm from the data environment that yes, there's no issue. Then let's generate the log series. Let's generate the log series. We will generate the log series by running a line of code in lines 31 and 32. Then let's do that. Let me also confirm, yes, no issue. Okay. Then I'm good to go. Okay. The available tests will be running, like I said before. These are the tests: augmented equivalent test, PP test, KPSS test, ZA test, Clemente test with 1 break, and Clement test with 2 breaks. Okay. Now, and like I said, the package we are going to use, okay, is UR stack. We call it package because it consists of different commands. Okay, it's like a library for command of all these tests. Okay, all these commands, the commands for each of these tests is associated with this UR stack library. So if you are here to install that, so you can install the package by running the line of code in lines 45. Then to read more on it, so you can just run the line of code in 46. Then that will give you detail about the package. Now let's run the standard unit test, that is ADF test, PP test, and KPSS test. So this is the command name, then followed by the name of the variables I want to carry out unit test on. Now, these are multiple variables. So I have like 4 variables. I have like 4 variables there. Then comma test. Then in bracket, I put the name of the test I want to carry out. If it is 1 test, I put 1 test there. The name of the test 2, 3. So here I want to run the 3 tests at the same time. So let me run this test. That is the code in line 49. So if I run that, so it generates. So we have to wait because it will take few minutes. Can you see? Okay. Can you see? You can see we have the test here. Okay. Here you can see for ADF, you can see ADF test. Okay. We have constant and trend. Okay. If you want the one with no constant and trend, so we had additional option to our line of code. That additional option will be no constant. We are going to add no constant there. Okay. Now you can see log of GDP, log of exchange rate, inflation is TU. It's only inflation that is stationary, okay, at level. Only inflation is stationary at level, okay. When our model has constant only, you can see here, okay, you can see here. You can see at first difference here, you can see the variables that are not stationary at levels are not stationary. You can see log of GDP is not stationary. Okay, log of GDP is not stationary. You can see log of exchange rate is not stationary. You can see inflation is not stationary. You see trade opening is not stationary. Okay, so we don't need this second difference again because we have achieved stationarity at first difference. Okay, another thing I need to explain here is that look at this. Of you can see most researchers do not pay attention to this. You can see here, you have constant, then you have trend. Okay. Most standard papers present just one test, whether it's constant or trend, and they will not even tell you whether it is constant or trend. Okay. What they do in that situation is that they use the most significant specification. For example, look at this one. The most significant specification here for log of exchange rate is minus 5.73. Okay, you can see this is more negative. Minus 5.7 is more negative than minus 5.4. Okay. Another thing you need to pay attention to here, look at this one here. For log of real GDP, This is more negative. That is with constant. Speculation with constant only is more negative than with trend and constant. You know, what you can infer from here is that trend is unnecessary. Okay, trend is not that necessary in your log of GDP. Okay, that is what, if you look at the specification, you see that that time the question of the trend is not significant. We see that's why we use e-views like that. So we see you see the coefficient of the time. Okay, because it has been argued that if time, if your variable is not trending, okay, and you include trend in your specification, it's going to reduce the power of the test, and that's what has happened here. Including trend in the specification for log of GDP has reduced the power of the ADF test. What do I mean by reducing the power? It has reduced the ability to reject the non-hypothesis under ADF. That's what it means. Hope that is clear. So let me know if it is clear.
So please, I have a question.
Okay, what is the question?
Okay, so we are looking at the absolute value. So the one that has the highest, that is what we should
Yes.
Is that what you mean? Okay.
Yes.
All right, thank you.
Okay. Now, another thing to need to pay attention to is that ADF is always negative. ADF test is always negative. If it is positive, if the value is higher, that series is not stationary, is explosive. Okay, the condition, you know, in elementary class, they will tell you if the calculated value is higher than the tabulated value, that is wrong. For ADF, if the calculated value is more negative, that's the correct statement. It's more negative than the tabulated value. It's more negative. Okay, you can see we have minus 4.26. It's more negative. Okay, that is another thing I need to say here. So you can also compare the result here. You can see even for PPT too, you have inflation stationary at level, only inflation. Okay, while other variables we can achieve stationarity at first difference. You can see. So we stop at first difference here, okay, because we have been able to achieve stationarity. Okay, you can see for PPT2, it shows that we should go with the speculation with constant only. Okay, with constant only, and for TO, so we go with constant and trend. Okay, some papers will present both constant and trend. Okay, you hardly see economic series with no constant and trend. Okay, series that can have that specification, there are series like output gap, series like exchange, like interest rate spread, like returns, oil price returns. Those are the series that can have zero mean value. Okay, zero mean value. That's when you compute the average. How can we have zero mean value? Because in returns, some returns can be negative, some will be positive. At the end of the day, when you find the average, it can be zero. That's the only situation that you can have a specification of unit truth that has no constant and trend. Okay, that is why the specification with no constant and trend is not that popular. Okay, because most economic series do not have place for that. Okay, now also look at the confirmatory test. The confirmatory test. Although there's no disagreement between PPT and ADFT, okay, so we do not need this. Assuming there's disagreement between the two, so we can now show this, okay. So now look at this. We also have for this KPSS. You can see KPSS now test. You can see the non-hypothesis of KPSS is different from that of PP and ADF. Okay, rejecting the non-hypothesis like this one, the test is significant for KPSS. It means that the series are not stationary because the non-hypothesis for KPSS is that, look at it here, that there is stationarity. Hope that is clear. I want to believe that is clear. Hello?
Yeah, so whenever we have the start there for KPSS, that means that series is not stationary.
Yes, not stationary because it is significant.
Thank you.
It means we reject the non-hypothesis. Okay.
The non-hypothesis.
Yeah.
Thank you.
So, and you need to read what we have below here, that you have three, when you have 3 star, it's stationary at 1%, but you know the conventional level of significant level is 5%. Okay, once you have 2 star, okay, you are good to go. All right, so we can also run the other test, okay, that is unit root test with structural breaks. At times, series might be stationary, but because there is a break, 1 or 2 breaks in the series, okay, maybe from between, let's say we have a series between 1990 and 2025. Let's say between 1990 and year 2000. Let's say the series is stationary if you partition your series into 2. And from 2001 to 2025 is also stationary. Okay, when you partition into 2. But when you run a unit root test on the series from 1990 to 2025, and the series becomes non-stationary. So the reason will be the fact that there's a structural break. Okay, there's a structural break that have broken the series into 2. Okay, that structural break is making the series not to be stationary. So in order to account for that, okay, that is why Zybot Andrew Clemente now develop alternative to this standard unit root test. Okay, that is why wherever you have conflicting results here, for example, this one says not stationary, this one says not stationary, this one, even if this one says not stationary, all of them says non-stationary, or you are able confused. So it's always good to also use structural break unit root test, because non-stationarity means that your series has structural break. Okay, because when you run a structural break unit root test and your series becomes stationary, but your standard unit root test shows that series is not stationary, it means that your series contains structural break. That is the problem of the series. That's why it's not stationary. Okay, now these are the structural break tests we are going to run. So we have ZA, we have lemma 01, 02, 01. You can see we have high 01, high 02. So I01 here, you know, we have 2 versions here, like I think I've explained here. We have innovational outlier, then we have additive outlier. Innovational outlier could be sudden, okay, sudden shift, okay, and you can also have a gradual shift. Okay, now let's run this. Let's run this. So this one will take time. Okay, so you have to wait and let's see the results. So while that one is running, so we can also read the recommendation here. Look at the recommendation here. The recommendation says you are going to find this recommendation in F5. Say run ADF and PP as the primary unit root test. Okay. Use KPSS as confirmatory test. Okay. If ADF and PP, if ADF, PP, and KPSS agree, it means you have strong conclusion, okay, of stationarity. But if they disagree, the series may be near the boundary. Okay, the series may be near the what? The boundary. So in that wise, there's another test you can use. We call it ERS. It's also available in the F file there. It's also available in the F file there. Okay, so it may be, if they disagree, it may be that you have you have a near unit root. A near unit root, that is the coefficient of the coefficient that determines whether your series contains unit root or not is very close to 1. If that happens, so the ADF and PP test has low power. They have low power. Okay, so we are still going to talk about this anyway, but let's look at this other. You can see even accounting for structural break. So log of GDP is not stationary at level. Okay, but at first difference is stationary. You can see this D here means first difference. This one is second difference. Okay, it means first difference, then second difference. Okay, now it's stationary at first difference. Okay, but if you look at this Clementi test, it says that accounting for it said accounting for two breaks, the break in 2020, 2003 and 2011, the series is stationary at level. That is, log of GDP is stationary at level. If you use Clement, you can see the importance of accounting for unit root, for breaks. Okay, so also look at it. Okay, Clemio 1 also indicates stationarity at level if you account for breaks. I will have used one variable to demonstrate this in order not to waste time. I hope that is clear. Hello? Hello?
Yes, it is clear.
Okay.
Yeah, please stress more the Clementa structural break test there. Can you explain again?
Okay, I said at times ADF and PP test, we say the series is not stationary. Okay, that does not actually mean that series is not stationary. It may be there's a break or breaks in the series. Okay, let's say for instance you have a series. I made mention of series between 1990 and 2025. There are some events like economic recession of 2007, 2008. You have COVID-19. Okay, all those have introduced breaks into economic series. Okay, they can make economic series not to be stationary if you don't account for those breaks. Okay, there are some unit root tests that account for those breaks, that factor in those breaks, because ADF tests and PP tests do not account for those breaks. Okay, so accounting for those breaks, okay, the series may be stationary. What I'm saying is that if series are not stationary using PP test and ADF test, and we now apply structural break unit root test, and the series becomes stationary. So the problem is that the series is stationary. The problem is not that series is not stationary, but the problem is that series is stationary, but there's a break, the presence of breaks in the series. Once we account for the breaks, so the series becomes stationary. Hope that is clear.
Yes, it's clear. What I'm just saying is that the interpretation of those values for the Clementine
Yes, it's the same hypothesis. It contains so the same direction of the hypothesis. Okay, once it's significant, it means the series is stationary. Okay, for example, look at this. Clamor AO2. It is significant. It means the series is stationary. Hope that is clear.
Yes, it's clear.
So that is it.
Yes.
So we can also look at other tests. I think we have 4 more minutes. Okay. So there's other tests here. Why that one is running? So we have other unit roots like bonded you have. There are some variables that are bonded, like interest rate. Interest rate, we assume interest rate, the band of interest rate, that the lower band of interest rate is 0. Okay, it's bounded by 0. So there are some authors that argue that that can actually affect the series. If a series is bounded, that it has the highest or the lowest value, it can actually affect the performance of a test. So that is why a test is introduced. That is bounded unit root. Okay, so I think we can go through this in our subsequent class. So we are going to dwell more on this. Okay, we are going to dwell. So we can also play around it. So because this do file is actually self-explanatory. You wanted to say something? Hello? Hello? Hello?
Hello.
So,
Hello.
okay, yes, I'm with you.
Okay. You asked whether we understood. Yeah.
Whether?
I just want to. No, I didn't understand. I just to ask them of that are saying that what allowed we need to do it on the access without
It's not, the voice is not clear. Can you repeat that?
I'll send chat. I'll send chat. I'll send chat.
Okay.
Yeah.
I can hear you now.
In terms of the you that the problem, how true is that?
I can't hear you. I can't hear you at all. Maybe you can send me a message either on the group or in private. Yeah, attempt the question then. But I can't hear you clearly. Okay, please, I want us to play around all these second test so that in our next class we won't waste time on this second test. Okay, we won't waste our time on this second test. So I'll be ending the class now. You know, it's already